Now it's on. There we go. Okay, so any questions about the homework assignment? I mean, the test itself. Exam 1. No questions?
Oh.
Yeah.
So I used your code to start with.
Mm-hmm.
And one of the first steps was to randomize the direction.
Yeah.
When I took off, but it wasn't already doing that?
It may be.
Okay.
It may be doing that already.
Okay.
Okay, so let's go ahead and get started with this project because I do want to show you guys, if there are any questions, go ahead and ask. And I'll start up my little thing here. Alright, so I got AI starter ready and got this ready. Okay. So the first thing I would do is, if you want to choose to use my project as a starting point, the first thing is to download it and then re-upload it as a project. Okay, so we go to project and then we say import project from my computer. And I think I have demonstrated how to do this in class because there were a few questions regarding how to do that during the exam. Alright, okay, so we got the project all loaded. So what I'll do is I'm just going to read my own instruction and follow my own instruction step by step. The sequence of the instruction is actually, there are 3 chunks to it. So the first chunk is pretty easy, okay? Just change the configuration of the properties. Okay, so there's no need to write any code, just make sure the properties are changed accordingly. So I want the speed to be 10, radius to be 25, interval to be 100. Okay, that's applicable to the ball itself. So I want interval to be 100, it's already 100. Radius to be 25, so change it from 20 to 25. Speed is 10, and it is already 10. So that's it, okay? I got the first part of the requirements met. The second part is to add the quote-unquote survival time logic to the blocks. So this time I do require some blocks to do it. When the game starts, randomize the direction of the sprite. Okay, so we go to the blocks here, and we say, okay, when we start the game, we have to do certain things. So the first thing is to locate that code. And obviously I need okay, there we go. Initialize game is a subroutine, so we go to the subroutine itself. Okay, I'm gonna rearrange things a little bit. Sort blocks by category, there we go. Alright, so this way we can have initialize game here, and I already have the randomizations because I already have this block here setting the heading of the ball with a random number. So it's already done. Okay, I have just done a few steps for you as far as the question is concerned, which also means those particular steps probably will not carry a lot of points. Certainly not all of the points. Okay. All right. Second thing, add a global variable survival time. Okay, if you don't use the exact name of survival time, I'm not going to take any points off. If you just say survival or just ST in short, that's okay with me. Uh-oh. Is the lock not working? It's working or not? Okay, thank you. Alright, so what we'll do is we'll just do this. Survival time is a global variable. So let's start with declaring the global variable. I keep trying to tab through instead of just changing the tab here. Okay, so we'll go to take a look at our global variables, and then we'll instead of just HP, we have to add a new one. Go to variables and say initialize, and then this time we call that survival time to 0. Okay, so we'll just go ahead and initialize it with some constant. 0 is fine, whatever you want to put here is actually not very important because there will be a specific place to get it initialized. Okay. All right. I did it again with a tab. All right. Okay, the purpose of the global variable survival time is to keep track of the number of seconds past the start time until the game is over. Use an additional clock for this timing purpose. Now, you can't use the same clock for everything, okay? That is actually possible. However, it does make your code a little bit harder to understand, and it complicates the code quite a bit. So the easier approach is to use a second clock to do this. So go back to the design view, because that's the only place where you can drag and drop a new component onto your project. So you go to sensors, drag and drop another clock. So now we have two clocks. One is clock 1 and the other one is clock 2. Now as far as clock 2 is concerned, we have specific things that we want to make sure. We don't need it to be enabled to begin with. So I would take out enabled because I don't need to enable the timer until the game has started. Okay? Because otherwise it will keep ticking. If it keeps ticking all the time, then you will need some other way to track, okay, has the game started? Has the game started before you actually do the increment and do the counting? So I would just turn it off until the game has started. Okay? Timer always fires is okay because it only fires when it is enabled. So you can keep that one enabled. And then timer interval is specified in milliseconds. 1,000 milliseconds is exactly 1 second, which is what we want. Okay. So we got all the stuff here done correctly. We go back to blocks, and then we have to do some logic here. So we go to clock 2. There's only one event a timer can generate, and that is a timer event. So whenever clock 2 ticks, okay, has a timer event, the only thing we want to do is to increase the survival time. So we go to survival time and increase it. So we go to variables, we set survival time to survival time plus 1. So that's a math operation, it's an addition. So we have to add survival time by 1. This is the only one class where it takes me longer to actually put the blocks together than talking about it. In my other programming classes, I can typically type a lot faster than I can talk. This is the only class where I can talk faster than I can put things together actually in the program. Yep?
You can do type. Yeah.
You can type some of them.
Like numbers and things.
Yeah, numbers you can type, but
And
for
even
the
variables, like something.
Yep. That's cool. Okay, so we got this working, and let's go back and check again. What else do we have to do? Okay, we got the additional clock. When the game is over, make sure the timer is stopped. Okay, so we go back to here and go to the place where we can detect when the game has stopped, and that certainly is related to the collision of the ball reaching an edge. Okay, so if global HP is less than or equal to 0, this is where we can detect that the game has stopped, it is over. And this is also where we show the notifier and say game is over. Alright, so we just need to add some additional code here. We want clock 2 to be disabled at this point. So we go to clock 2, go to its properties, disable timer enabled, put it here, go to logic, specify false, to make sure the clock is no longer ticking when the game is over. Alright, so we have most of the logic here. We also need one to specify when the game starts. We also want to start the timer. So that would be when the button is clicked. Okay, so we have to add another block here for clock 2. Go all the way down to set timer enabled to true. So we can just duplicate this block, stash it here. Okay, go back to the assignment, make sure that we got that one done. Okay, this one is to use a label to reflect the value of survival time, this variable should increase increase by 1 every second, which is also what we just said a little bit earlier. Okay? So we just need a label and then have the logic to change the label whenever we update that particular variable. Okay, so let's go back to the design view to put in that label. You're not required to do anything fancy, but I'm going to do something just a little bit fancier than dragging and dropping a label here. I go to layout, go to horizontal arrangement, put one here, put my start button in here, and also put my label in there as well. Okay. There we go. But I don't want it to be here, I want it to be on the other side. There we go. Oh, it doesn't like that. There we go. Okay. Okay, the text originally can be just text 1, it doesn't, or text for label 1. It doesn't matter all that much. We only have one label in the entire program, so I'm not gonna change the name of the label. Alright, so now we have to spot the code to change the number, because when we change the number, we have to update the label. So right here in initialize game, we have to initialize the survival time as well. So this would be a good place to change the label. You can turn this into a subroutine if you want to. Okay, so every time you change, you increment, you also change the label. But we can, for this program, we can just kind of sprinkle the code a little bit. I'm just personally curious about the lock in the door, so I'm just going to check it out first. Did the handle turn?
No.
It wouldn't turn on the outside?
Nope.
That's our new security feature. Alright, so right here we set the global variable to a 0. So survival time, we'll reset it to 0. Right here. And we also want to change the label so that it reflects in 0 as well. So we go to the label, which is all the way here, and set the text of the label to global variable survival time. And this is why I don't like graphical programming, because it just pushes the stuff all over the place. Okay, variables. Oh, get the global variable survival time. Okay, so when we start the game, it is automatically initialized to 0. And when we end the game or when we increment, it also has to change. So we have another one here. So just duplicate this block, put it over here. Okay, so I think we got most of the basic stuff done. Okay, so we'll give it a try before we go any further. How many people tested the program like just occasionally to make sure it is working before? Okay, very good. Okay, so instead of trying to put everything in and then test it at the very last moment, I think it is better off to test it occasionally. You put in some code and you say, okay, the program should now do blah blah blah, and in a visible way, test it first, see if it works. If it does not work, it doesn't make sense to go any further, because it is whatever you do next after this is not going to work either. Was the exam challenging, or was it based on the amount of time that you can use? Was it challenging, or was it kind of like, it's okay?
Easy. I couldn't get the clock to work, so
okay.
it took me the longest time. I I just submitted what I had
Okay.
at the end, and then when I went home, I was able to figure it out. So,
Okay, what about you guys?
Challenging.
Challenging?
Yeah.
Okay.
Yeah. I'd say it tested our knowledge that we currently have.
Sorry?
It tested our knowledge that we could teach in the class.
Yeah, I try not to put in too much new stuff to it. You know, in other words, most of the stuff are things that we have already used. May not be the same way that we have used them in the past, but nonetheless, the same kind of components. So, what was the most challenging part? Why was it challenging?
The score, or at least the notification of you beat the high score.
Okay.
And that was only because I was not following computer logic, and I was setting the score equal to whatever the current score is, so it
Okay.
always considered the current score to be the high score.
I see. Oh, okay.
So then I found a way around that, but I had to think computer logic.
Okay. Well, that's the whole point, to it,
Yeah.
because in programming, you have to think in computer logic. Anyone else want to kind of?
I had an issue with the clock, only because I internally reset the equal counter to different number than it was supposed to be.
Internally reset the.
Because in your code, there's a part where you set the regular clock to an angle number for interval, and I did the same thing. It was the same number, so it was every half second opposed to every second.
Okay. Anyone else?
mine, I couldn't get the clock to work because I didn't understand about the timer always fires.
Uh-huh.
And I had that feature disabled when I created the clock.
Right. Because in the first application, we wanted it to be a one-shot timer.
Right, and so this time I couldn't get it to work
Yeah,
because
okay.
it was disabled and I didn't enable it once the program started.
I see. Okay.
So I tried to work around the duration and time and stuff, but I kept getting errors because it was just runtime errors.
I see.
It would compile okay, but it wouldn't run.
I see. Okay, so you can see the timer is actually increasing just fine, and I'm going to let the game game over, so I can test whether it will stop the timer as well, because the timer is supposed to stop when the game is over. I specifically specify the speed this time because some of your projects made the ball bounce so quickly that I could not test it because I cannot click fast enough. Okay, so game over, the clock stopped, and it displayed just game over. So I got the timer working okay now. Okay, so that means I can now proceed with the next stuff. Okay. Okay, with this all done, we want to add the high score logic. The high score should be stored in TinyDB so it is persistent. Use the tag name high score to store this value. At the end of each game, store high score, load high score from TinyDB. If high score is not defined yet, use 0 as the default value. If the survival time is greater than the high score, do the following. Use a notifier to display a message and congratulate the user that he or she just broke the high score, and then store the new high score into TinyDB. All this logic is going to be in the logic where we say, okay, game is over. Okay, so we attach that logic, the entire logic here. Everything here will go to that place. You can use a subroutine if you want to. I mean, it makes sense to turn this into a subroutine so that you don't complicate the code too much in the blocks here. Okay. So I'm going to do what I just said here. Did anyone use subroutines in this particular program? Okay, you did?
For this section I did, I put it into a subroutine.
Yeah, it makes sense because then the logic is kind of on its own, and you don't have to worry about it messing around with all the other code. So I'm going to define a new procedure. It doesn't have to return a value, doesn't have any parameters, because we just make use of global variables and TinyDB. So in this logic here, the first thing we want to do is to get the score from TinyDB, and if it is lower than your current survival time, we want to update the TinyDB so it uses the new survival time. So I am going to try this first, okay? I'm just going to try out the if block here, okay? I don't even bother to use a local variable. I don't think I need to use it, but we'll find out. Okay, so the conditional block is going to be based on comparison. So we go to math, and then we compare two numbers, and we'll compare something is greater than. In other words, we look at our current survival time and see if the high score that I have stored up to this point is smaller or less than survival time. So to do that, I need to go to, oh, I don't have that block yet. Okay, let's go back to designer view and drop in a tinydb. Go to storage, drop in a tinydb, go back to blocks, and now we can use tinydb. So go to the tinydb block and pick out a particular item here. The only one I think I need is to get a value, at least at this point. So I'm getting a value. I toss away the default value tag not there because I want that to be a 0. So I go to math, drag a 0 here. This is the default value of 0. The tag name itself, okay, I think this is where you can just start typing. So you can type, is it just text? Or, oh, let's see if this will work. High score. Nope. Yep, there we go. So if you just type quote, it will automatically turn it into text, and when you press return, it will put it into the first empty slot of the current block. So this block here is going to do all of those things. Well, so many of those things that we just mentioned, because it's going to try to retrieve the value of high score from tinydb. If it is not already stored, it will return a value of 0 by default, because of the way I set up value if tag not there. Okay, and then I proceed to use that number to compare to my current survival time. If the current survival time is greater than the high score that I have stored up to this point, I will proceed to the then portion of this conditional statement. Okay. The only thing I want to do, well, there are two things I want to do in the conditional statement in this part here. The first one is to update tinydb so it stores the new high score. So that would be this tag, this block here. Same tag as before. If you turn this into a global variable, into a string with just high score, it's better, but I don't require that in the exam. So if you just copy and paste it, that's cool. The value that I want to store is just my current survival time. So this will remember the new high score. Are there any questions about the conditional block, the if-then block? Okay. And then the next thing I have to do is to do a notification. I have that code already, I think up here somewhere in the collision part. Right here. So I'm going to duplicate this, and let's see if this works. Can I use the backpack within the same program? And the answer is yes. Yay! Okay, so the exact message that I want is, oh, just to congratulate the player just broke the high score. Okay, fine, we'll do that. Okay, you just high score. Okay, there we go. All right. So this logic is still sitting just inside the procedure, and I need to change the name of the procedure to check and set high score, okay? Just so that the name of the procedure reflects what it does, and then I have to call this procedure, invoke it from inside the game over logic, which is, oh, this block has nowhere to go. Let's toss it. Where's my trash can? Here we go. Into the trash can. And this is the game over logic, so we have to call the procedure from here. Go to procedures, call set, check and set high score. We put it here. And I think that's it. Okay. I don't know. We have to test it. So go back to the emulator, which is right here. Start the game again. So the current intention is just not to beat the high score, just let it time out and see if it will tell me that I have just broken the high score, because the high score should be 0 at this point because it's not even stored. When you're testing, you can always lower your HP so it will game over quicker and then change it back when you're done. Okay, so game over, and it should tell me that I just broke the high score. Okay, so that's good. My current high score is 31. So I will test it again. Okay, so let's go ahead and start it again. And this time I will make sure that it does not, it will exceed that high score. So it will give me another congratulation again. Okay, there we go. That should do it.
Timer should start from 0 every time. And it should continue the timer. Timer
Which
should
one?
start from 0 every
Yes.
time you start.
Yeah.
I thought it would continue.
Well, it's for timing how long you survive each game. But I won't be taking too many points off, just for that. Okay, so it has already exceeded the high score stored up to this point. So it should give me a congratulations screen this time. There we go. So game over. And here's the congratulations. Now just because it gives me the congratulations this time doesn't mean the logic is working. Because it may think that I have broken the high score when I did not break the high score. So the next time I'm going to test it without clicking it even once. So this time it will game over before I break the high score. And this time it should not give me that congratulations. Okay, game over. But it should not tell me that I broke the high score. And it did not. Okay, so everything is working. Well, just because it's working up to this point, okay, somebody can be using a global variable to keep track of the high score, right? So the next test is for me to run this as an independent application, close out the application, come back in, and see if the high score is still remembered. Because that's the only way that I can use to test your program to see whether it's using TinyDB or not. Now, with this program, I'm fairly sure that it is using TinyDB and it is persistent, okay? Because I do not store the high score anywhere in the program, not as a global, nor even as a local variable. So I'm fairly sure that this program is going to work regardless. But some program may have used a global variable to keep track of the high score and not storing it back into TinyDB properly. So I will have to test for those, and the only way to test it is to install the app independently and then just see if it works that way or not. Okay. Are there any questions at this point? No questions? Okay. So here's an idea. Okay. In the future, when you need to do something with a particular component and somehow it is not working the way you want it, the best way to do it is to just read the documentation first. Now, I know this is a lot of stuff to read when you're in an exam, but most of the time, this is how I would basically resolve issues when I have questions about, okay, this is not doing what it's supposed to. Why is it not doing what it's supposed to? Timer always fires, has a really bad explanation because it explains will fire even when application is not showing on screen if true, but it also means it will keep on firing every time you click it will fire again. So the next thing I would do, let's say I could not figure this out because the documentation doesn't really quite clearly state that it will keep firing whenever the timer has expired, because this can be interpreted in a different way. Okay, so let's say that is not clear to me. So I would have my timer. Okay, let me go back to my timer or clock 2, and I will have it turned off like this. So the program is not going to work properly this time. Okay, it will get stuck. it doesn't take again. So if I go back to the emulator, I will show you the bug of this program. So let's start the game, and it will stop. Oh, it still counts. Now this is curious.
Yeah,
Yep.
mine I didn't have time for all those fires. It worked fine.
It worked fine?
Yeah.
Okay. So that means it's always, that is weird. So as long as it's enabled, it keeps ticking. That is interesting. I thought you need that one because then the documentation doesn't seem to jive with my understanding. I'm like, well, that's bad documentation. No, the documentation is actually correct. It's just that it's not required for the timer to keep firing repeatedly. Okay, so any other questions? So if you want to make this app so that the high score is not just on the device itself, it's so you're having all people who install this game to compete against each other. How would you change this program? Just with 1 or 2 blocks to make it work that way.
Wouldn't you have to take in their name first, and then you could show that to the thing?
Okay, so you need a name, so you need some kind of quote-unquote registration. Okay, good. And then what else?
And then you would have to show that in TinyDB saying that, hey, this person is playing this score.
But TinyDB is specific to a device.
Or not TinyDB, the one
Firebase.
Yeah.
Yeah. So
Firebase.
you have to use Firebase, but for the rest of the program, it will still be pretty much the same logic. The only thing about Firebase is you can request to get a value, but it won't get back until later. So you will have to separate that block into 2 halves. That's the only downside of using Firebase.
But also once you use the value, wouldn't you have to compare?
Yeah, you still have to compare. It's just that, okay, let me show you which part I'm talking about. So this game over logic here, okay, if I go to the procedure, the request to get a value is not going to be the same place where the value is returned. So you will have to separate it into 2 parts, where at the end of the game, you request the current high score, but then you have to stop. When the high score comes back from Firebase, then you do something about it. Okay, so you have to break it up into 2 parts. But that will make the game a little bit more fun because now you can have as a number of people who have this game installed to compare and to compete, and and you can also maintain a list of the high scores if you know how to sort. So that can be a lot of fun. Any questions about this particular question? Well, the only question in the exam. No questions? Alrighty. If there are no questions, I'm going to go back to my projects because we are not quite done with lists yet. Okay, so we are going back to key value pair. I cannot remember which program, so I'm going to pick out this one. I think it is this one. And then we go to blocks. And I think this is the one where I can remove a certain item from a pair. So it does have a certain feature already. So what I'll do today is I'm going to work on something that will allow your program to maintain a hierarchical key value pair list structure, just like a folder, within a folder, within a folder. Okay? So this will allow you to locate items relatively quickly. Okay? Let me just explain what I mean by that. And I will do it on screen because this way it is going to be recorded. And it also is easier to look at too. Okay, so when you look at a folder structure, okay, in Linux at least, it starts with a slash, which is the root folder. In DOS and Windows, just backslash, okay, same thing. Okay, this is the root folder, it is the top level, which means this is my top level list. And then within the top folder, you can have a number of folders, right? You can have temp as a folder, and in Linux, I have home as a folder. Within temp, okay, so temp is a subfolder. I can have some files. I can have, well, I don't know, test.txt as one file. I can have I don't know, swap .bin as a file, okay? And then under home, which is in the root folder, I can have one folder per user in home. So I can have one under my own name. I can have another one under the name of a generic user. So I can basically have a hierarchy of stuff like this. I think most of you have used Windows long enough to understand, what I mean when I say you can have a folder inside a folder inside another folder. Okay? So in the case of a list, okay, if I want to turn this into a list using key value pairs, this is what I would do. Okay, the root folder is a list by itself. Okay, if I have nothing in the root folder, it would be just an empty list, has no items in it. Is that okay? But I have two folders. In this case, I have two items. Each item is representing one thing in the root folder. The first thing that I have in the root folder is called temp, TMP, and it is a folder itself. So this is the name of the first item. This is the value of the first item. It is a folder. The second item is the same thing. The name is home. It is a folder. It's a container by itself. Are we still doing okay so far with this analogy? So I'm going to say that test.txt is a file, is not a folder. Swap.bin is also a file, it is not a folder. Okay? So those are the two items inside the temp folder, which means inside here I have two items, 1, 2. The first item is test.txt, and then its own content is, I don't know, just maybe it just has ABC in it. Okay. The second item is swap.bin, and it has some gibberish content. We'll just say 1, 2, 3, 4. Let's say it's a number. Is that okay? If I just rewrite this in a certain way, I think you will start to see the parallelism between the top and the bottom. Okay. Is that better? Do you see how the list representation is kind of mirroring the folder structure? So in the second case, inside home, what do I have inside home? Well, inside home we have two items. Okay, so we have one item, and now we have the other item. The first item is a folder with a name of T-Oil. So the name is T-Oil, it is a folder. The second item has a name of user, it is also a folder. Is that okay? Because at this point, I did not list the content of the two subfolders, so I'm going to stop here and just call it and just say that, okay, they may be just empty. Are we still doing okay so far with this representation? Well, why do we even talk about this? Why is this useful as far as your app is concerned? How many people? Go ahead.
You need to know how many lists to make, and then what values to place in those particular lists.
Exactly. Exactly. So we want to be able to traverse this, okay, and locate a particular item. Okay. All right. And we have some basic features to do this already. Okay, we have some basic features to do this already. All right, so the next thing we want to do, just one more thing, okay? What if I want to specify swap.bin, okay? What is the quote-unquote full specification of path to swap.bin? In Linux, it starts with a /, okay? That's the root folder. Temp is a subfolder of the root folder. And then swap.bin is a file inside that folder. So we use this particular notation to say, okay, I want to specify the file called swap.bin in the temp folder, which is in return in the root folder itself. So what I want to do is to do something like this, but with structured key value pair lists. Okay, so I want to write a procedure. I want to write a procedure that says, get item from pair. Well, structure pairs. and inside I want to supply, a list. Okay, so the list is going to be just, temp and swap.bin. Okay, this is a list, like so, and it will give me the value of swap.bin, which in this case is 1, 2, 3, 4. In other words, I want a very convenient way to get to specific items in a structure of key value pairs. Is that okay? Do you guys know what I want to do? Okay. All right. So let's go ahead and do this and see how we can write that procedure. Okay. So I'll turn this into a procedure first. And this time I'm going to use a special kind of procedure because it has a result. It's going to give me back something that I can use for something else. Okay, because it's going to tell me what is the value of that particular item. There are several things that we need to do first. The first thing is to change the name. I'm going to say get item from structured key value pairs. Okay, I'm just abbreviating key value pair to KVP, okay? Because otherwise the name of the procedure is going to be quite long. It will need several parameters. Okay, so the first parameter is what is my KVP, key value pair. So this would be the structure, the folder structure itself. The second item is what I call path, okay? The path here is really equivalent to this specification, but I will break it up into items in a list. So the path itself is going to be a list. Each item on that list is going to be the name or the tag at one particular level. Is that okay? All right. Okay. All right. So we're almost there. Okay, and I'll give this one more item. I'll give it one more input. Okay. Let's see. Because I need a way for this thing to tell me that it could not find it. Okay, what I'm looking for cannot be found. So I will give it a value if not found. Okay, so this will be a parameter. It is going to default to the value not found if the item is not there. All right. Are there any questions about what the procedure is supposed to do? It's going to retrieve a particular item in a structured key value pair like this. Okay? It's a convenience feature. You can do it on your own using the other type of blocks, but this is convenient because it will give you the ability to make a really, really big, flexible, and complex structure of stuff that you want to keep track using just lists. But it will give you a quick and easy way to get to any particular item. Okay? All right. So let's go ahead and see how we can write this subroutine here. What I'm going to do is a demonstration or exposure more than what I expect you guys to be able to do in this class. Because some of you are still taking cisp362 and you have not encountered subroutines yet at this point. Okay? For those of you who have taken other programming classes and you know what subroutines are, you may not understand recursion well enough to do this either. So I'm not expecting anyone in this class to come up with this code, but if you can follow along the logic of this code, that's great. Even if you cannot follow along with the logic of this code and you know how to use it in your program, that would still be useful. That would still be great. So there are multiple levels of values with this particular procedure here. The first one is if you're an experienced programmer already and you understand recursion, you can probably come up with this code on your own and probably improve on it. Okay. Second one, okay, if you're taking cisp362, you will eventually see a recursive subroutine. So this is an early exposure to what that stuff is about. Third, if you don't care about programming, you don't care about recursion, you just want to get your app to work properly, and you are going to use structured key value pairs, this is going to be a utility subroutine that you can make use of in your own project. So there are 3 levels of values. in this particular subroutine. Okay, so we are gonna have to figure out, okay, what are we gonna do with this? So what we'll do is we go to control first, and I will start off with this. This is a very typical thing about recursion, is you start with a conditional statement, okay, not a loop, okay. So the interesting thing about this is you would think that we need some kind of a loop to drill down to the thing that we want. Well, I'm going to use recursion to do that. Not necessarily the most efficient way to do it, but it is one way to do it. All right. So, but I do have to make sure one thing first before I can do this. Okay, so I have to see if I can make a list out of the rest of a list. And if I cannot do that, then I won't be able to do it the way I want it. Yeah, it doesn't look like I can do it this way. Oh, okay, bummer. Oh, I cannot do it that way. Sorry. No recursion. Okay, we have to do it the boring style. The boring style is to do it without recursion and use a loop instead. Okay. So we have to go to, okay, let me see if, where are we supposed to put this? We might need a local variable, so I'm going to put it here. And then inside control, I need something that can return a value. Okay. Do result. Okay, there we go. All right. So since we cannot do it using recursion, I'm gonna have to use a loop to do it, which is kind of boring, but it's, you know, it has to do it. We have to do it this way. All right. So let's see how we can do this. The first thing we need to do is to see if see where we are in the path. Okay, so we need some kind of a counter to tell us where we are in the path. So the first variable that I have here is going to be called a path index. It is telling me which item of the path I should be focusing on, because the path itself is a list. It has multiple components. And I'm going to set this to 1 initially, because this is the first item that I need to look at. Is the first item is number 1. I think I can still do this using recursion. Okay, maybe not. Alright, so I've set path index to 1, and in the do part here, I'm going to have a loop, because I need to go through the entire path in order to find the thing that I need to find. So inside the control, I need some kind of a loop structure. The most general loop structure is a while test type of loop, so I put it here. I use math to do to perform a comparison, and what I'm comparing is path index versus the length of the list itself of the path. So I will compare that to the length of path. And as long as it is less than or equal to, I will stay in the loop. At the very end of each loop, I'm going to increment path index so I can move on to the next item. So I would go to variables and say set local variable path index to 1 plus the same thing and 1. Oop, okay. Just did something that I did not intend. There we go. Okay. So now whatever we do has to be between the beginning and the end of this block here. Alright. At each level, what I need to do is to keep track of the key value pair that I have at that particular level. So but that's going to be KVP itself, So I need to find the name. Oh, I forgot to specify. Oh, the name is actually part of path already. So I need to use the first item of path as the tag, and then the first item or the top level of KVP as the list of key value pairs, and see if I can find the value of that thing. So I need one more variable, and we'll call that I'll just call it item here. And it doesn't really need to be initialized to anything special, so an empty string is going to be okay. Okay, so in the loop here, the first thing we need to do is to go to lists and make use of a built-in block called lookup pairs. So this will allow me to look up everything automatically, and we want to set item to this thing. I need to specify three things. The first one is not found, and then we have pairs, and then we have key here. Pairs is going to be my KVP, and then the key, oops, attach here, and then the key is going to be the first item of path. So once again, I go to list, and this time I want to select the first item of the list path. Nope, not the first item. I want path index. So get, oops, wrong one. Path index is a local variable. Okay, there we go. So let's take a look at this block here and see whether we know what it's doing. Okay, set item to. Okay, that's pretty easy. I'm just changing my local variable item to something. What is that item? Well, it's based on the lookup in a key value pair list. The key value pair list is KVP itself, which will change later on. And then the next thing is what is the key or the tag? The tag is going to be one item in path based on path index. In other words, we're moving down the path index one by one, and then we see, okay, can we find that item at that level? If it is not found, we want a very specific value to indicate not found. So what I'll do, just to be safe, is to initialize another local variable here, and we'll say not found gibberish. Okay. And really initialize that to a gibberish of some kind. So we'll specify some really actual gibberish. Okay, I think that's gibberish enough. The chances of you storing something like that in your TinyDB or in the list is pretty slim, okay? If you do, then we might be shocked. All right. And we'll use it as the value not found. Okay, so we get this as the value not found. Okay, there we go. All right. So this is an attempt to see if we can find that one item that we're looking for at a particular level in the hierarchy. Okay? So how do I know whether that thing is found or not? Well, we can compare that thing to the random value. Okay, I need to exchange the order of these two blocks. So the first thing we do is to locate up first, and then potentially we might increase the path index. Okay. Okay, next thing, what do we do? Well, we have one potential of actually finding the item that we are looking for. So we need to check whether we found it or not. So that will need a conditional block here, and we'll put it right here. There we go. So what we're comparing is going to be a string compare, where one end is the gibberish stuff of indicating something is not found, and then the other side is going to be the item that we have retrieved. Okay. Here we go. All right. So if it really is the same, okay, if item has the value of the default value of something not found, that means, okay, we can stop now because I haven't found the item that I'm supposed to find. Okay? So that means there's nothing to do in the then case when they are in fact the same. But the else case means, okay, if I look at the else part here, it means the item that I got is not the default value of not found, which means I found something. Is that okay? All right, if I find something, I actually have to do something about it, because what I need to do is I have to remember that I just found something and potentially change my KVP so that I'm ready for the next level. Okay? So there are two things I need to do here. Let's see. Okay. I can just do that one thing first, okay? Let me see if this will sufficient. So I'm going to change KVP to item because I found something. Item, is actually found. So let's see, duplicate. Okay. So this is how I move down one level. Okay, I'm saying, okay, now we're moving down one level, and then we keep doing the same thing, but after we change the path index to path index +1, so that we are looking into the next item. Okay, we have two potential issues here. The first potential issue is when we get back to the test here, path may no longer, no, this part is still okay, but we want to get out of the loop when one of two things happen. When do we get out of the loop? In other words, when can we make a conclusion and say, it's time to, I'm done here. When I found the item that I'm looking for. Now that can only happen when path index become greater than the actual length of path. Because that means I have exhausted every single item on the path and I found the last item. Okay? What is the other way to give up and go like, well, I'm done? Not finding, right? Not finding it. Okay, so not finding it has two ways to there are two ways to detect that we're now done because we couldn't find what we're looking for. Okay, so let's go ahead and specify that logic here. But what I also need is an or. Oh, actually, no, take it back. What I need here is an and, and we'll put the and over here and make this the second half of the and, because we need to check something first before we even look at, okay, have we exhausted everything on the path? Okay. The first thing we'll do is to see if item is the same as the not found gibberish, because if it is, that means, hey, it's not found, it's time to get out of the loop. There's no need to go any further because I cannot get past a certain point of the path specification. Okay, so that's, once again, is based on this comparison. So I'm just going to be lazy and replicate this part all the way over here. Okay. So now this whole thing basically says if, okay, this has to be not equal to, because we are specifying when we stay in the loop. So we go back to logic and specify a not over here. So that means if the item is not the not found gibberish, and it should not be because that's not how it's initialized, and we still have some more items to go through in the path, then keep going. Is that okay so far? Okay. But there's also one more indication that we should stop. If KVP is not a list anymore, I can stop right away. Because KVP is supposed to be a list. But at some point, if I get to a file, but the path says, oh, we still have a few more steps to go, I can stop right away because I have located the file instead of a folder. So I can stop. So that means I can have another logical and, put it here, put this become the second half, and the first part here is go to lists, and check if KVP is still a list or not. So we go all the way down here and we ask the question, is KVP still a list? Because it has to be a list in order for this thing to go. So we have a fairly long condition at this point, because this entire condition, to stay in the loop, it is saying the same thing as long as KVP is still a folder, is a container, is a list, and we have found the item up to this point. Okay, there's no confirmation that we could not find it. And on top of that, we still have more paths to go, more items in the path to go, then keep going. Is that okay? The logic is kind of cumbersome, but this is how the way it works. Come to think about it, I think recursion would actually work too, and it might actually make the code cleaner. When this loop is all done, okay, what can we conclude as the result? How can we conclude the result here? How do I know that I found what I'm looking for?
Use a multiplier.
Not that. I suppose you can use that too, but there's one clear indication that we have just found the item that we're looking for.
The item matches.
Well, there are two things. So you're right. Okay, the not found value is 1. Go ahead. Think about how we can get out of the loop. Okay, there are 3 ways to get out of the loop. If we look at the condition of the loop here, there are 3 ways to get out. The first one is when KVP is no longer a list. But that's not a reliable way to get out. Okay. Because we set KVP to the item, but maybe that's the item that we're looking for already. So KVP not being a list is not an indication of whether we found the item or not. Get item is the same or is not the same as not found gibberish. If it is, it's a confirmation that we didn't find it. If it's not, it is not a confirmation either.
It's just not gibberish.
Yeah, it's just not gibberish because I may be not going through the entire list of the path. I found a file instead of a folder, and that's why I stopped. But in that case, it's not going to return gibberish. It will just have some kind of content. Okay? So that's not going to be helpful either. This one is actually a good indicator because what we can do here is to say that we move this block into here. There we go. That should do it. In other words, we are not even going to bother to change the path index unless we did find an item. So that means, if path index is in fact greater than the length of path itself, that means we are done. Because that's the only good reason to get out of the loop. Okay? All right. So here, as far as the result is concerned, we go to control and we locate that if-then block that can return the value. And then the only thing we can do, or that we have to do, is to go back to here. I'm being lazy here. Replicate this block, okay, duplicate it, put it in the backpack. Oh, yep, okay. Get all the way to the bottom. The joy of graphical programming. And retrieve it here. Okay, less than or equal to is fine. Okay, we just reverse the polarity. Okay, if path index is less than or equal to the length of the path, that means we did not really quite go through the entire length of the path itself for one reason or another. But whatever the reason is, we didn't find what we're looking for. Okay, if we did not find what we're looking for, then there's one specific value I should return, which is value if not found. It is one of the parameters. On the other hand, if it is greater than the length, if path index is greater than the length of path, that means I actually went through every single item of the path, including the last one. Okay, and that means, yeah, I just found what I was looking for. And as a result, I can now return item, because item is the one thing that I found using this block here. So I can specify item in this case. Okay, all right. So this is I claim this code works. Okay, the question is, does it actually work? What do you think? You cannot just look at this code and find out whether it works or not. I certainly cannot. For one very specific reason. I can't even see the entire block of code. Okay? Because the screen doesn't give me enough space to actually display the entire code, and it's really hard to debug a program when you cannot see the entire program. Okay? So I'm just going to say, well, it probably is going to work, but I'm going to test it. Okay? So I have, in the designer, I already have some part of it, that can be tested, but I can specifically make a test list here to make it to test this particular thing. Okay. So what I'll do is I am going to put in another button here. You can see this program is quickly becoming a quite messy program. And I'm going to rename this button and say generate test, and change its caption to reflect that. Generate test. Okay. So generate test is not going to do anything really complicated. It's going to generate a test. That's all it's going to do. So it's going to set a global variable. Okay, so go to variable, set a global variable. Let's test KVP to, oops, I used the wrong one. We just need to initialize to an empty list. And then when the button is clicked, then we'll do something fun with it. So we go to button gen test. When this button is clicked, then we'll set my global variable test KVP to something complicated. All right, so let's see what we can do with this one. Let's go back to our sample code here. Let's say we want to do this, okay? Something like that, probably not as complicated, but I do want to have at least 2 levels of folders or KV key value list, so I can see at least whether I can go through multiple levels or not, and then we can test it that way. Okay, so at the top level, we're going to create a list. Here. We'll make a list of 2 items. The first item is also going to be a list. The second item is also going to be a list. Okay, because each one has to be a key value pair, which means it is already a list. A key value pair itself is a list. Okay, this is my temp folder, TMP, and this is my home folder, home, like so. Okay, the temp folder is a folder itself, which means it is going to be a list. Home folder is also going to be a folder, so it is also a list. There we go. All right. In the test code, the temp folder has 2 individual files. Okay, but each file is also a list. It's also a key value pair because it has a name and it has its content. So that's why we still have a list here, except now This is going to be the individual file called test.txt, and the content of this is just ABCD. The second one has a file name of swap.bin, and has a content of 1, 2, 3, 4, as in 1,234. Are we doing okay so far looking at this and equating this construction of a structured list to what we talked about in the mouse pad, in text? Is that okay? All right. All right. So temp is okay, is done. Now we go to home. Home is a little bit more complicated. Well, in a way, because each item in home is by itself a folder too. So we have two folders. The first folder has a name of TAUYEUNG, but it has an empty list as its content because it's an empty folder. Is that part okay? Does everybody understand why it is an empty list associated as the value of TAUYEUNG? Because it's an empty folder. It is a folder, except there's no content in that folder. The second one is about the same thing. Okay, so I'm just gonna, okay, duplicate, stash it here, and duplicate this, stash it here, change this one to user. Okay, so now we have a full replication of everything that we talked about earlier. Okay, and this button is just going to do this. Okay, it's just really testing whether we can do this. What are we going to do to test it? Well, we'll use another button to trigger the test. So let's go back to the designer view and use another button to trigger the test. So we drag another button into here, and we say rename it to test. Change the caption to test. And then I need another label to indicate the result of the test. Okay, so I need two more things. I need a label, I need one text box, and I need a label. Label, where's the label? Here we go. Okay. The label is going to be test result. The text box is going to be the path. Okay, so this is where I can specify the path to retrieve so I can display it here. Okay, so if I go back to my blocks, I can now make use of these components. So go back to the blocks, and I go to button test, and say when it's clicked, I'll do something. This time I do need a local variable. So, well, do I need one? I don't really need one, but it's helpful to use one. Okay. Okay, let's see if I can do it without using one. So what I'll do is I'm going to set label test results text to the result of something. So I will set the text of label test result to the result of calling my own procedure, the one that I just made a little bit earlier, get item from structure KVP. The KVP itself is going to be the huge variable that we made earlier. So that's going to be a global variable. And we called it test KVP, I believe. Here we go. The path is the interesting part. Okay, I have a text box, but how can I convert a text box into a list? I'm trying to see if you guys remember something from the functionality of a list. Okay, let's go through the list and see if you can spot something that can be useful here. All right, we'll start from the beginning, and you guys can say, okay, would that help? Yeah. Not directly. Okay, so none of these is gonna help much. Let's scroll down a little bit. Anything here that might be helpful? I don't think so. Anything here? I see something starting to become useful. Okay, the CSV thing. List from CSV role. Okay, this one. Okay, so let's check out what it's saying. It says right here, parses the text as a CSV comma separated value formatted row to produce a list of fields. It is an error for the row text to contain unescaped new line inside fields. It's okay for the row text to end with a single new line or carriage return line. Okay. In other words, you can give this particular block a piece of text with values separated by a comma, and it will turn it into a list. Hey, that sounds like what we're looking for, because I have a text box already. So we'll feed the text of the text box to this thing. Hopefully it is a list. It will give me a list, and I can take that list as the path to the function or the procedure that I'm writing. Okay, so we'll take out this item, stash it here. The only thing I need to now specify is where is the text to convert into a list? It's my text box. So in the text box, I can now get its value, get its text value, stash it here. And then we just need to specify, what if it is not found? What kind of gibberish do we want to specify here? Okay, all right, so let's see. We can have our own gibberish here, so we can go to local variables and specify our own not found gibberish to something. So we'll go ahead and specify that something to be, oops, okay, that really is gibberish. Okay, I think that's enough gibberish here. All right, that one can go. Put it here. That's it. That's my test. Is that okay? All right, so let's give it a try. The emulator should be running this code. Oh no, it got out. All right, fine. We'll have to reset the emulator. Reset the connection, and then run the emulator again.
So when you have the comma separate values, is that something that you can use in my program as well? Basically, hard code in the first name, last name, and the address, or no?
Yeah, you can.
So that means that would you have to then create an Excel, and after the Excel do a comma separate value so that it knows?
Well, you can do that. I think there's also a way to read it from a file too. I can't access it right now because it's trying to hook up to the emulator, but I think there's a way to read it from quote unquote a table. Okay, so we click generate test, and then we can ask okay, that's interesting. Alright, so I can ask for TMP. Done. Nope, it didn't go there. Oh, I type on my own keyboard. It has to be TMP done. There we go. All right, so now we can test. What do you think we should see from TMP? It's going to be a list of the two quote-unquote files. Okay, so let's click test. Attempt to get item number 2 of a list of length 1 temp. You will not see another error report for 5 seconds. Okay, so this has to be coming from my own procedure, and it's complaining that I'm trying to access more things than it has. attempt to get item number 2. Okay. Okay, so let's take a look at this part here. To stay in the loop, I want path index to be less than or equal to the length of the list path. This is how I got it to increment by 1. They should have exited already. Let me read this one more time. Select list item. There's only one block that I use with the name of select list item. Attempt to get item number 2 of a list of length 1. And that's the list that I gave it, which is just TMP all by itself. The question is, why does it try to get to item number 2? Okay, let's dismiss this. So we are looking at this block here. It's complaining about this block because it has the name of select list item. And path index at this point is a 2. So maybe I did not do the comparison correctly. If path index is less than or equal to the length of the list path, stay in the loop. So if I stay in the loop, path index should not be 2. This block should work. And I specify and. Well, I'm gonna stop the recorder, and you guys can take a break. If you want to see how this works out, you can come back after the break. But right now there's no new homework assignment. Okay, we'll get back to that on Wednesday. We do have your project to go, okay, so you might want to kind of keep thinking about how this stuff is going to be helpful for your project. So does anyone have any time to spend on your project lately? Okay, that's good. Any questions about your project? Nope, it's all good up to this point? Okay, alrighty. So I'm going to stop the recorder because it's going to be recording mostly me talking to myself to debug this program. Because right now I'm